All right, so 9:10, let's get started here. So really today we're going to go through something very simple, but it's going to be very, very important for really any data science or any analysis project you do in R, which includes, geospatial data and precision ag related, but really extends to any other type, which is we're going to be talking about how to set up your folders to have a more organized workflow, and also using RStudio projects, which we're going to be talking in a second here. Okay, so to start today, I did send an email last night asking you to download the latest GitHub repository. If you did that already, then you have that first step covered. If you did not do that yet, you have to come to the GitHub page of the course, and you would click on that green code button. So this is something I just want to say for this one time. Our main goal here in this class is not to teach you how to use Git. We're just using GitHub as a tool. If you use Git yourself, you already know how to use it, you have everything installed, and you don't want to be simply downloading the repository every time. If you want to do a pull or pull the data, the repository directly through Git, you're welcome to do that. If you don't know what I'm talking about, don't worry, because you don't have to do that. You can always just use the code and download zip. Every time I post a new data set or maybe a new partial script and also the complete scripts after a class, it's always going to be through GitHub. So just going to continuously need to be downloading the newest version as we develop the course. So if you have not done yet, please go ahead and download the zip. If you haven't done since last night, since I sent the email last night, please download that zip file to your computer and unzip that folder. What I want to show you here is, once you have that repository downloaded, I want you to, we're going to set up some folders here to make things go smoothly. So if you do not yet have a folder for this course on your laptop, on your computer, so something like, I don't know, 2023 Advanced PA or whatever it is, you name it. If you don't have yet, please go ahead and create one, because we're going to have that main folder as the main structure. So I just want to show you in my case how that looks like to me. So this is my main folder. This is 2023 Spring Advanced Precision Ag. You can call it whatever you want. It doesn't have to be the same name, but have a main folder, okay? So inside this main folder is where you can always bring the newest version of the GitHub repository that we update. You can always bring that here. You can overwrite if you want, because this folder here, I do not intend for you to create your own materials out of that folder. I intend you to just use that as a source of new things coming in. So you can always just overwrite when you download a new one. So once you do that, once you do have a main folder for the course, and you have, you can go ahead and bring the latest GitHub repository that you just downloaded inside of this main folder of the course. So please go ahead and do that. And I have some more things here that you don't have, but one of the things that you will have that I have here is this new folder. So inside of your main course folder, I want to create a folder called 01 Data Wrangling, like that, like I have there. So please go ahead and do that. Okay, so you can think of this, if you're doing research, if you're in grad school or undergrad and doing research, you can think of this as a folder for a given project, like your research project. Let's say you're collecting data on yield of cotton somewhere. You can think of this as the analysis for that specific project. So 01 Data Wrangling. Now I want to go inside of this folder you just created, and I want you to create 3 subfolders. So the first, here's an alphabetical order, but it's not the order that I'm going to tell you, but the first one is going to be data. The second one is going to be code. Let me see if I can. Yeah. So data, code, and output. Okay, so why are we doing this? If you worked with data before, and especially if you worked with more than one data set, you know how easy it is for you to just have one folder where everything is all mixed together. We have data, code, plots, tables, perhaps a Word file, an Excel file, all together in that craziness that we tend to do. So here's just a way for us to organize a little bit different types of data, okay? So you're gonna have a data folder, which is where you're gonna put your data sets. You're gonna have a code folder, which is where we're gonna have the scripts that we're gonna develop in class. And then we have the output folder, which is targeted for us to save our plots and our tables that are products of the analysis that we do. Okay, so now I really need your attention here because to do this properly is going to set you up for class today. If you miss something here, you will not be able to follow. I'll guarantee you that. It's simple, very simple, but it's important. So please follow along. So right now I'm inside that 0-1 data wrangling. I want to get outside of it. So now I'm at the main level of the course folder. I want to go, so in my case, I have copied and pasted the GitHub repository inside here. And again, I have the latest version. So I'm going to go in there, in that folder from the GitHub. Kind of increase here. So the first thing I want you to do is go on 03 data. So this again is coming from GitHub. This is where I'm going to put the data sets that we'll be using in class. So you should see a soybeans.xlsx inside of this folder. Again, this is coming from GitHub. If you do not have this, it's because you do not have the latest GitHub version. So go ahead and download that again from GitHub. Assuming you do have soybeans here, you're just going to basically copy that and get outside of the 03 data, get outside of your GitHub, local GitHub copy. And you're going to see now the main folder of the course, go inside the 0-1 data wrangling, which is what we're going to do today. And go inside the data folder and paste the soybeans XLSX. So we're basically just taking data set I share with you, bringing into use so we can use today in class. Okay, everyone was able to do it? All right. So next thing we're going to do is very similar. So I got outside of the data folder. Now I'm at the 0-1 data wrangling level. I get outside of that and go back to the main folder of the course. And I again see the GitHub folder that we downloaded. I go inside of that and I go on class code. So 04 class code. And I want you to copy the data wrangling partial code that we have there. So just copy that. And as you may have guessed, we're just going to get outside of that folder. Oh, that's fine. Yeah, I have 3 because I did some extra stuff. But yeah, so the important one that we want to copy is the 0113 data wrangling partial. That's the one we want to copy. So we copy that. So get outside.
Could you say that again, or I missed that?
Sorry, can you repeat that?
Can you say that again? I missed that still.
You missed which one we should copy?
Yes, sir.
Yes, so we should copy the data wrangling partial, the 0113 data wrangling partial that I have right now. And again, if you don't have this script on your GitHub copy, it's probably because you don't have the latest GitHub version or GitHub repository version. So please go ahead and go back to the GitHub class page, download that, and you should see then this file. Okay, so I'm gonna copy a different one here, but you go ahead and copy the partial. So we get outside of that. Now we're at the main folder of the GitHub repository that we downloaded. Get outside of that. We go back to the class main folder. Now we should be seeing the 01 data wrangling folder again. We want to go inside of that and then inside of the code subfolder and paste the 0113 data wrangling partial. I have a copy here, but you wouldn't have. Let me just do this. Yeah. Okay, yes.
What was the thing we needed to come before that?
So before that, it was the data set. So the data set was in the GitHub folder, and then it was on 03 data. So it was a soybeans.xlsx data. You copy that into your data folder of the project, 01 data wrangling. Okay, so again, this is very simple, easy to do. But if you were not able to do, you're not gonna follow along what we're gonna do next. So if anyone is, I guess maybe I should ask this. Does everyone have the structure that we just went through? 0-1 data wrangling main or folder. We have the code inside the code folder, and we have the data inside the data folder. Everyone has it? Okay. I'll take that as a yes. All right. So this is pretty much how I would set up a folder structure for every single project I do. This could be from my research, from class, from everything. I always follow this. I have a main folder for that project, in this case, 0-1 data wrangling. And then I always have code, data, and output. And this helps me to get organized and really not have a messy environment when working with. Now, this is really, really important for, regardless if you're using R or not. But now I want to show you a tool that RStudio has that is really, really helpful, especially with relative paths. So remember the previous class, you were exporting your plots to desktop, or at least that was the goal. So RStudio projects helped us to make that path a lot easier and a lot straightforward than not using RStudio projects. So let's go now inside of RStudio. So if you just launch RStudio, I'm just coming to my search bar and just searching for RStudio, launching any RStudio window. I'm not double clicking on any specific script to do this. But maybe if that helps you to launch RStudio, then go ahead and do it. But the important thing is that you have an RStudio window. You don't have the same one as I have here, because this is from a different project that is actually the class website. But so if you see here on your screen, you probably have here saying preview none or something like that. That's because you're not currently in any specific RStudio project, and I am. So my project is called Bastos Lab. So let's go ahead and create a project for today's exercise. Okay. So to do that, you would click on your preview none right there. So that on the top right, and then we'll click on new project. Okay, so click there, new project. So we're gonna have to select some things here. So first thing is just asking if we already have a directory that we want to make our project, which we do, is what we just created with the 0-1 data wrangling directory. That's the main project directory. So we do have, click on existing directory. And then the path it gives you here is probably, if it gives you any path, is probably not the one that we need. So click on browse, and on your computer, wherever that is, look for that 0-1 data wrangling folder. That's what we want to. So again, this 0-1 data wrangling folder should be in your main class folder, right? We just created this folder. So if you select that folder, this is the level that we want to create the project. So not on your main Precision Ag main folder, not inside of code or data or output, but inside of 0-1 data wrangling, you should be seeing the code, data, and output subfolders at this level. This is the level we want to create this project. So you can just, once you're there, once you're able to browse to this level here, you click open and create project. And then it's basically going to relaunch RStudio, but focused on the folders or on the folder structure that we selected. So this is something, you should be seeing something similar to what I am seeing here, once you're able to do that. Okay, so if you were able to successfully do this, you will on here on the bottom right on the files tab, you should see this like 0-1 data wrangling.rproj icon, and you should see the code, data, and output folders that you already created previously. So this is really important to stop and ask. If you need a second, if you got stuck, let me know. Yes.
All right, so I saved it within the code and data files, everything, but whenever I'm in RStudio, can browse for it, and I click on the folder, type scan, and it doesn't show it.
Okay, let me come to you and help.
I think I got it now.
Browsing.
How is your someone for Tiffany for this class?
So, just.
Yeah, that is.
And just show me. Just show me the folder, like your main, course folder. So. That's okay. So here, so this is your GitHub, right? Yeah, that's everything. So here, so we want to do is here, yeah, but that's fine. I mean, as long as it's in the folder, so here we want to have 0, 1 data. And this item, and then inside of here is where you want to have the full data. Markup filters. So let's do this. And here is where you go. And then okay. So I think you're set up here. So now let's into our studio. Double check it. It should work as we just checked, but this one should. Anyone else here? Yeah. So was it this way when we were doing this, frequency? There's a mention. Okay, so now I'm not sure what's going on, and we can look if that keeps happening, but we're back out. Look into that. Well, everyone else can hear nothing's. Okay, I don't see any issues. Everyone else online was able to, let me just bring the camera here so I can see you all. Everyone online was able to get to this point?
We're having some issues, but give us just a split second and we'll have it, I think.
Okay, let me know if you need some help from me.
Uh,
You don't do the whole thing?
Okay, so while we got some Tifton students figuring things out, I just want to tell you why, and this, we're not going to be coding yet, but I just want to tell you why first having the folder structure, but also using RStudio projects is really, really helpful. So one thing is, especially in grad school, we're probably going to have a whole bunch of projects, right? Maybe you have 3 different fields, you do 3 different years, and you start collecting a whole bunch of data within each one of those situations. You will grow a lot of data and a lot of analysis scripts and all that. You do not want to have all that mixed in a folder because it's going to be mayhem, especially if you need to do something quick. It's going to be a very messy if you don't have a structure. So first, having a structure of like project name, and then inside of that project, having the 3 subfolders, code, data, and output, which is helpful already. RStudio projects helps you a lot because it focuses your view of that RStudio window to that project that you're using. So here today, we're going to do the data wrangling project. So you can already see that on files here, the files tab is already showing me that view of this project that we set up. So if I go under code, I should see the script. To go back to the main project folder, I click on that R blue button. And I can go back and make sure that data is there and output is empty at this point. So it's really helpful because it focuses you on that project. This is helpful for one reason, that is importing and exporting files. If you do not have a proper working environment like RStudio projects to manage your projects, it's going to be very difficult for you to find the correct paths to import and export data. Using projects, that's really, really easy to do. You're going to see that in a second here. Also, another thing is, as you start developing more analysis for different things, you want to be able to switch quickly from, oh, I need to go back to another project I was working on yesterday. I want to, refocus on that. You can do that very easily here. So if you go click on here, you're not going to have anything, most likely, if you haven't been using RStudio projects. I have a list of things. So just so you know, the website that I share with you, I do that in RStudio, and I have a project for it. So if I want to go back after class, go back to that project and, give you the recordings and the code, I would simply just relaunch that project, which is going to open another RStudio window, refocus my view entirely on that project. So now I am on a different main folder, different files, completely shifted my view, right? So this is really helpful if you have lots of projects going on. It really helps you to switch quickly between them, and all the files related to that project will be there. Okay, so this was a little bit about RStudio projects. Is everyone in Tifton good to go? All right, let's get going then. Okay, so last class we talked about, or we did all of our programming using RScript, which is a .r file. If you remember how it was basically mostly code, and we had some comments that I had to use hashtag to make that a comment. Today, I'm going to be introducing you to a different file type. So if you go on your project that you have open, if you're not seeing the main folder of that project in RStudio, you can click on that R blue button. If you don't see that R blue button, maybe if you just toggle here to increase the size, it will appear. If you click on that, it takes you to the main folder of the project. Click on code and click on that code that we pasted there. That should open this code here on the top. And I'm just going to minimize my console here so you can see better what's going on. So this is a .rmd file. I did introduce you the first time to a .r file, which is the most basic, perhaps, script file in R, which is fine. A lot of people still use it, but .rmd is better. And here's why. So it may be looking a little bit weird the way it is, but it has a few different components that is really important that I want to show you. So one is the concept of a chunk. So this is a chunk. And on your side, maybe colored differently, but you know it's a chunk because it starts with 3 apostrophes and ends with 3 apostrophes. You can kind of think of this as what we were doing with the R script yesterday, where you type your code and inside the chunk, if you have comments, they have to be with hashtag. However, outside of the chunk, so this is a chunk, this is outside of the chunk. You can write comments as you would on a Word file, for example, right? And this is not going to be interpreted by R. It's not going to give you errors. So it's really helpful that you can write as you would normally outside of a chunk. And what you're going to see in a second here as well is that the main cool thing about R Markdown files is that it incorporates code, output, and comments all on the same file. So whenever the code inside of a chunk, if that code creates a plot, that plot is not going to appear here on the right. It's going to appear right below that chunk. So you can really follow through and everything is going to be on the same file, kind of like telling a story, everything together. Really, really handy. For me, when I learned about this the first time, it was a game changer. So just wanted to expose you early to this as well. So we're not going to be using .r files anymore. It was just so you were aware of them, you knew they existed, and that's it. We're now moving to R Markdown files only. Okay, and also something you're going to notice here is on R Markdown, so if we use the hashtag outside of the chunk, it actually serves to determine hierarchy of your levels. So if I do a 1 hashtag, that's like a heading 1, if you think of it on Word. If I do 2 hashtags, that's a level 2. So let's say I do test. If I do 3 hashtags, it's going to be a level 3 heading. And you can see here as well, we have an outline. If you're not seeing the outline, if you look like this, you click on that outline or maybe on that icon, it will show you the outline. And you can really see that the headings are appearing there with the proper indentation. So just so you know that outside of the chunk, a hashtag does not make a comment, it makes a heading of some level. Okay, so I left you already here everything that we needed on this first chunk, so you don't have to program anything. Something cool about chunks is that you can just run all of it at once. So I want to invite you to hit on that play button. So that play button is basically going to run all the lines that we have programmed into that chunk. If you run it, you may get a message. Well, you're not going to get a message because I said message false. But if you get an error saying given a package not installed, it's probably because you have not installed one of these packages. You already know how to install a package. If you need to, I don't have to walk you through that. But just to remind, you use the install.packages function if you have to. You shouldn't have to because these packages were all part of the getting ready for the class packages. Okay. So let's finally, we don't have a lot of time left, but we'll start at least working on this today. So today, and probably at the next time that I meet with you, we're going to be doing data wrangling. If you've never heard of it, data wrangling is just basically like data transformation, data management. Imagine when you're doing things in Excel, if you're copying and pasting, given columns, you're using pivot tables to get summaries, or you're creating new columns, whatever it is, using formulas. That's what we're going to do, but in R. And I really, really urge you, throughout this course, I will urge you to do data wrangling tasks in R. Again, doing Excel is not reproducible. We may create error that you're not even aware of. In R, if you do make errors, that error is documented via code, so you know exactly what you're doing. Okay, data wrangling, right? That's the topic today. Let's start. So the first thing is that we need a data set. Let's start by importing this data set here. So I want to call this data set soy-k. So I already left you there the name of the object that we're going to, let's say, save this data set that we're importing. So we use the, assignment symbol that we learned already. And there is a function called read_Excel that comes from that read Excel package that we just loaded above. So if you just, select that function, open and close quotation marks, have your cursor blinking in between them, and hit tab. So what happened right there is it's basically because we only have one file inside of the script folder, it's just giving us that file. So right now, our path
Dr.
is.
Bastos,
Yes,
here in Tifton, there's two of us that don't see, read Excel when we're typing it in. I didn't, know what to do.
so that, yeah, that function comes from the read Excel package. If you run that library read Excel and it gives you an error saying you don't have installed, you just have to go ahead and install it. So you would basically just do like install packages and then open and close quotation marks and read Excel. So if the read Excel function is not appearing for you, it's because your read Excel package was not properly installed. So it's, if you're having issues with that, I can definitely help you after class. I just wanna keep going because we don't have too much time today anyway, so it's not like you're gonna miss a lot from today's coding at this point. But if you're still having issues with the read Excel function or read Excel package, let me know after class and I'll help you out to get that through. Okay, so if we come back here and you have your cursor there, what happens is right now our path is inside the code folder, which is not where the data is, right? So we need to get outside of the data of the code folder and go inside the code folder. Get outside of the code, go inside data. How do we get outside of a folder using relative paths or just a path? We do .. // So that basically takes you one level up on your folder structure. So now if you do .. / and hit tab, you should be at the main level of your project. And again, we want to bring a data set, which is in the data folder. So at this level, you just click on data. And if you click tab again, it's going already to populate with soybeans.xlsx because that's the only data set we have in that folder. If we had more files in that folder, it would give us the option to select. Okay, so if you do this and you run that piece of code, you should see the SoyK object up there. And I just want to print this object here so we can inspect this data set. So if I print it, notice now, this is one cool thing is the output of printing this object is a table, and that table now is appearing on the R Markdown file itself. It's not appearing on the console as it was yesterday or the previous class with the .r file. So again, this is one of the cool things about R Markdown is that you really mix together code, output, and narrative. Yes.
It's not loading. It's showing that file is not there and check in the folder, file is there.
Do you have the Zero on Data Wrangling project appearing on top?
Yeah.
Okay, let me double check that. This should be quick.
No, I can come after class.
See what happens with you. Yeah, just everything, just leave all of them. So, and then, okay, so that is right.
No. So there's also like, I did, yeah, no, after class.
Yeah, we're gonna look into that in a second. Okay.
All right. So so if you just print this data set below here, what we see is that it gives us some columns and some rows. It's not showing us the entire data set yet. And I just want to show you here, it's saying that it has 16 rows and 8 columns. If we browse here on the bottom, we go to to see more rows? Yes. Oh, so I basically just ran the name of the object. Yeah, so that print just prints it. Yep. And so 16 rows, 8 columns. If you use here we go to the 2, it basically shows you the last rows because it's showing just the first 10 initially. And if you want to see the other columns, you would use that right arrow there to see. So there is a function here that is kind of useful if you want to be able to visualize the data set more completely, maybe like you would in Excel. There's a function called view. So if you say view and then you give the name of that object where the data is, it's going to show you in a new window. So let me just go back so everyone can see. And it is view with uppercase V. In our case is important. So make sure that's uppercase V. And then it should pop up a new window here where we see the entire data set all at once. So we see there's a plot column, there's a treatment number column, there's a crop stage column, potassium rate in pounds per acre, and then we have potassium percentage on trifoliates and soybeans at 4 different locations. So Tifton, Midville, Watkinsville, and Macon. Okay, so we're going to be using the view function throughout this exercise just because it helps us to visualize better, but I just wanted to expose that to you right now. So this was a study. Yeah, again, this specifically is not precision ag, but every concept that we're going to go through today, we're going to be using throughout the course. So that's why I'm exposing you to this. So just to give you a little bit more information. So this was it's a fake data set, right? I made up this data set, but it's a good example of what could happen. So it's a study where the main goal here was to understand the effect of different potassium fertilizer rates on soybeans, potassium trifoliate concentration at 4 different locations in Georgia. And so we have a plot number. So it was the trifoliates were sampled at the R4 growth stage in soybeans. And then we have the potassium rate is our treatments. And then we have what we measured in 4 different columns. So potassium trifoliate concentration as a percentage in 4 different locations. Okay, so every time that we bring in data, any sort of data, we should always inspect it, right? So we talked a little bit about this. We should always look into it, see if it makes sense. I want to introduce you to this function called glimpse. So it's just as the name says, but it's all lowercase. And we're going to say glimpse soy K. So this is a different way of getting a summary of this data set. So we saw the function summary previously. The glimpse just shows us, again, how many rows, how many columns, and then it lists all the columns that we have. It tells us, again, if R is interpreting that as double, which means numeric, or character. So here we have just one character, which is the stage, and everything else is seen as numerical. This will become important in the future, so that's why I'm highlighting this. And then also, we already saw this function last time, but we're going to use the function summary if you come on the next chunk here. So function summary and soy K, which again is our data set. We're going to get a summary. So we should be familiar with this. We've already, but it basically takes each column and gives us a summary of what that column is. So if it is a numerical column, it gives us a statistical summary pretty much with minimum, median, and all that. If it is a character variable, it just gives us how many rows that it has, which is not very useful really to tell the truth, but the numerical ones are pretty useful, especially, we want to, again, if you have lots of columns, this is kind of a quick way for you to see if you don't have any NAs, if you don't have any missing data, if your mean and max make sense, right? So if I have a maximum percentage of 1,000, I know that's not possible or shouldn't be possible. So that would be, a red flag that maybe there was a data entry error or something else. Okay, so one thing I just want to show you, I just want to print again so you see what soy K is, right? So if you look at the column names, they have different, we have special characters here with parentheses, we have space, we have some that are all uppercase, some are all lowercase, some are mixed. This this is just a little bit not very consistent, right? And I think having consistency in names helps us when we're building graphs and models and all that. So I just want to delete that. The first data wrangling step I want to show you is how to use an automated way of just cleaning those column names. So we're gonna use the assignment function there, and there's this function called clean_names that comes from the janitor package. So we're basically just gonna say clean names, and the first argument it takes is the data set that you want to clean names. So that's the soy K, right? So if I run that, so if I have my cursor there and I just run that piece of code, and then I print what soy K1 is, again, soy K is the result of what we just did. We can see that now the column names have been standardized, so everything is lowercase. Wherever we had parentheses, now it basically removed the parentheses and just kept things pretty straightforward, easy to understand, no special characters, everything lowercase. This can be very useful especially if you receive data from other people and they're coming from Excel. We know that in Excel, we tend to use special characters like, things that are not numbers or letters. And that can be very tough to deal with when you're programming in any language. So just being able to automatically clean all the names is a really useful trick. Okay, so pretty straightforward, pretty simple first data wrangling step. Now I want to, what I want to do next is basically, let's say for some reason, I only wanted to keep the columns where the potassium rate in pounds per acre was 0. So we have 4 potassium rates, I think. Let's say I just wanted to keep the one that was 0. How can we do that? So we're going to use this function called filter here. So what we do is, if you just skip that names for now, just come to soy K_2, use the assignment symbol. We're going to use this function called filter from the dplyr package. First thing that we give it is the data, right? So the data that I want to give it is soy K_1. So make sure you're given the 1, which already has the clean names, and not the soy K, which is the original raw one. So soy K1, and now we give the condition. So the condition is we're going to say a given column equals a given value. For you to not have issues with like mistype or making a typo on the column names, let's just run this name soy K1 function here. So this function names basically returns you all the column names of that data set that you're asking. So I just want to ask you to go ahead and copy the potassium rate pounds per acre name right there. We're going to paste that here without the quotation marks, just to let you know. And if I want to so I want to show you here soy K1 again, just so I refresh your mind. So potassium rate in pounds per acre ranges from 0, 50, 100, and 150. So if I only want to filter the values that are 0, I say equal 0. If I run this, and then I print soy K_2, which is the filter version, it's gonna only show me the 4 rows that had potassium rate equals to 0. Now, this is a very simple, straightforward way of doing like a filtering on your data. You can really make this a lot more complicated if you need to, right? So let's say if you had multiple conditions and this data set was huge. I mean, we started with only 16 rows, so it's not like it's a very big data set. Let's say you had a data set with 1,000 rows and you only wanted to filter potassium rate equal to 0, location that was Tifton, I don't know, whatever other conditions you may have, you could just incrementally add them to the filter function. So it's a really powerful function to be aware of. Okay, so the next one is probably the last one that we'll see today is the function mutate. So the name perhaps is not very intuitive, but what mutate does is it creates a new column based on something. It could be a value you give it, it could be a formula. So if you think in Excel, when you create a new column and you give a formula based on another one, that's kind of what mutate does in our language. So here's what I want to do with the mutate function. If we look right now, our potassium rate is in pounds per acre. Let's say you're writing a paper and you have to use English units, right? So let's just transform that pound per acre to kilograms per hectare in this next step here. So we use the assignment symbol again, and we call the function mutate, open and close parentheses. The first thing we give it is a data set. And we could, if we wanted, we could use the soy K2, but I actually don't want to use soy K2 because that is only where potassium rate is 0. I actually want the clean version, but with all the data set in there, which is soy K1, right? So the clean names, but all the data is in there. So on the mutate here, let's give it the soy K underscore 1. And I just want to, I added a comma and I'm going to hit return just so we break the code and it's not as long in one line. And I want to call this, so the first thing we give now is the name of the new column. So it's going to be K underscore rate underscore kg HA. So K rate in kilograms per hectare. So this new column is going to be, it's going to come from, I just want to come back here just so you see again. I would just want to copy that name, the K rate pounds per acre, and paste that here. I mean, you don't have to copy and paste. You can type if you need to, but I just wanted to show you can do that. And the transformation here is something, you know, is basically just multiplying pounds per acre per 0.454 and divide that by 0.405. This is a good enough approximation to that transformation. Okay. So if we run this and we print soy K3, you should have the 16 rows because we started with soy K1. And if you go to on the right arrow, you go to the right, the last thing you see should be potassium rate in kilograms per hectare, which is right here. And it's great. The only thing I don't like about it is that it's giving me a whole bunch of decimal points that we don't need. So let's just fix that before we're done with this new column, potassium rate kilograms per hectare. So if you come here at the end of the 405 and you add a comma and you hit return, we can mutate again or create new columns. What I want to do is basically overwrite. So I'm going to overwrite on that potassium rate kilograms per hectare that we have just created. And I'm going to use a function called round. So this function here, the first thing you give it is the name of the column that you want to round. So that's again the kilograms, potassium rate kilograms per hectare. And then you add a comma and it has, the next argument is how many decimal places you want to round to. So just say 0 and run it. So if you have your cursor anywhere, you can just click run and it should run. And now if we print it and inspect again, now our potassium rate has no decimal points. So an integer, I guess. If you had issues, if your code didn't work, it's probably because you're missing maybe a comma in the right place. Maybe you didn't close the parentheses. If that happens, it's always helpful to see like where this parenthesis is closing. So this one here is blinking right there. So it's closing the round. And this one here is closing the mutate. So that's a way to identify that. All right. So I think this is a good stopping point. We're going to be doing maybe a few more wrangling steps to finish this exercise. That's going to be in our next time that I meet with you. So for today, we're going to stop here. So you can go ahead and click save on your script right there to make sure that your changes were saved. In next class, we can just start from where we stopped. And just some quick reminders. So no class Monday, that's going to be a holiday. Next Wednesday and Friday, you're actually going to be meeting with Dr. Lacerda, who is right here. So she's going to be talking with you about some different coordinate reference systems and some different GPS, I guess, explanation of how GPS works as well, maybe other topics. So next time that I will meet with you is going to be So the next Monday, right? So maybe in a week or over a week from now. And then when I meet with you again, we're gonna continue from here. So if you have any issues, if you weren't able to follow, let me know. Oh, another important thing. If you are here, if you're attending right now class, I want to ask you to go to our class GitHub repository. You go under issues, and I just created a attendance January 13th. So if you want to go there, just leave me a comment. It can be whatever you want. It can be, whatever you want to write in that comment, just so I know that you were attending class live today. Because I know some people were not able to attend today, and I just want to know who was able to make it live in class. So this is going to be your attendance. If you did not do this, I will not count you as being present today. So please make sure and do it to get your attendance in the records. All right, I think that's everything I had. If anyone had issues with setting up the project, with your folders, your files, if you had issues programming up until the mutate function, let me know. I can stay after class and we can troubleshoot anything. Other than that, you're good to go. Thanks, everyone.